Go 1999 question 4A. Two scale pans each of mass 0.5 kilograms are connected by a light inelastic spring which passes over a smooth light fixed pulley. Now remember, it's not rotating. The pulley doesn't actually rotate, it just slides over the top. That's the difference between this question and the moments of inertia type question. Okay? The mass of 0.2 kilograms is placed on one pan and mass of 0.4 kilograms is placed on the other pan. The system is released from rest. Calculate the acceleration of the system. Well, for all intents and purposes, we're actually going to treat them as one mass. So this is 0.7 g going downwards, and this is going to be 0.6 g going downwards as well. 0.9, excuse me. 0.4 plus 0.5 is 0.9, so it's going to be 0.9 and 0.7. Okay? Now that we've done that, we now realise that the 0.9 is going to travel downwards with acceleration a, and the 0.7 is going to travel upwards with acceleration a. We then set up two formulas. Okay? Tension is the same in both of them because it's slipping over the top. Remember, if it's rotating, the tensions are different, but it's not rotating. So we call it T and T. So we're going to say for the 0.7 g, okay, we'll just do it as 0.7 g, okay. So for the 0.7 g, what we can say is that T going upwards minus 0.7 g going downwards equals 0.9 a. That there is worth 5 marks. Then for the 0.9 g mass, okay, what's going to be is it's going downwards, which means 0.9 g, and then it's going upwards T, and overall it's going downwards at 0.7 a. Oh, sorry, not 0.9, 0.7, excuse me. It's 0.7 there. Okay, that second formula is also worth 10 marks, okay? Or sorry, 5 marks. 0.7 a, okay? Add them together, and what we're going to get is 0.2 g. That's 0.9 there as well. So it's going to be 0.2 g. Yeah, take them away from each other. And so just give me a second there. Okay. It's T minus 0.7. Ah, sorry. That's 0.7. I'm just getting this mixed up. 0.7 g, 0.7 a. That's 0.9 g, 0.9 a, because 9 is going upwards. Alright, there we go. And now what we're going to get here is 0.2 g ends up to be equal to 1.6 a, and the acceleration is going to equal g over 8, or 1.225 ms to the minus 2. Okay, that'll get you 15 marks. Now the final 5 marks go for part 2, and part 2 says find the forces between the mass and the pans. Okay, so forces between the masses and the pans. So what we need to do is draw a diagram of the pans. Okay, so what we do is we draw a diagram of both pans. Okay, now one pan has what mass in it? The what's it? The 0.7. Is it the point? The 0.7 one has 0.2 and the other one has 0.4. So this is a mass of 0.2 kilograms, and sorry, I'll just do a different colour. 0.2 kilograms here, and the other one's going to be 0.5 kilograms. Is that correct? Now, sorry? 4. Oh, 0.4. Excuse me. Right. Now, for the first one, okay, we're going to call the upward force R1. Okay, the upward force is R1, and weight is going directly downwards. So overall, the one with the 0.2 kilograms is going upwards. Okay, its overall acceleration is upwards. Now, what's connected to it? Technically speaking, the tension is connected to the pan, not to the weights. So technically speaking, it's going upwards, okay? And the mass itself, right? Force equals ma, and the mass's weight is 0.2. It's a mass of 0.2. Its acceleration is a. It equals the reaction force pushing it upwards, because it's, at the end of the day, it's like a lift. It's the ground that's pushing you upwards. Okay? So it's going to be the reaction force going upwards and the weight going downwards, which is going to be 0.2 G. Then we know what A is. A is what? A is G over 8. So it's going to be 0.2 times G over 8 equals R1. And then we'll move the 0.2 over the other side. Just rub this out for a second. Oh wait, I'll drag it across. Excuse me. Okay, so it's 0.4 kilograms in here, okay? So what happens is it's going directly upwards, okay? So R1 equals 0.2 G plus G over 8. When you calculate all that together, what we're going to get is R1 is 9G over 40 when you put it into the calculator. Okay? 9G over 40. Now, for R2, okay? R2 is once again going directly upwards. 0.4 G going directly downwards. But the overall acceleration is downwards, okay? So once again, force equals ma, which is going to be 0.4 times G over 8, because its acceleration A downwards. This time, the weight is winning, because it's driving it downwards, so it's the 0.4 G going downwards, and minus R2 going upwards. Bring R2 to the left, and that to the right. We're going to get R2 equals 0.4 G plus G over 8. 0.4 G over 8. Add them together, and what we find is R2 equals 7G over 2. Now, I want you to note something here. Oh, sorry, 7G over 20, as opposed to 9G over 40. Now, guys, which one's bigger? 9G over 40 or 7G over 20? 7G over 20. Now, look at this. When the overall acceleration is downwards, yeah, you feel more of a force going upwards. The ground feels more of a force, okay, when you're going down. When you're going up, what happens? When you're going up, you experience less of a force, okay? So just bear that in mind in regards to the overall acceleration. Alright, moving on. For big, okay? A smooth wedge has a mass of 4 m and a slope a. It's placed on a smooth horizontal surface. A particle of mass moves down the inclined face of the wedge. Show in separate diagrams the forces acting on the wedge and on the particle. Okay, so to get full marks here, okay, what you need to do is the following. You're going to have your wedge here, which is 4m. Okay, and this 4m has mg going directly downwards. Okay, so 4m, and I'll have mg going directly downwards. Okay, now it's on a slope a. So what you're going to do is you're going to resolve it down parallel and perpendicular. So that's alpha. That's 4mg. That's going to be 4mg cos alpha, and then 4mg sine alpha. You happy enough with that? Okay. Now guys, please remember, the wedge, guys, the object, the plane itself is only movable when it says the word wedge. If it says plane, it means it can't move anywhere. So overall the wedge won't have any acceleration. So here's your two separate diagrams here. You're going to draw your 4m going upwards like this, and all you have to draw, as you can see by the marking scheme, is your reaction force going up and your mg going down. Okay? And then on the wedge, what you have to remember about the wedge is that it has two reaction forces. It has a reaction force coming off the ground, off the table so to speak. Then it has a reaction force coming downwards, equal to the reaction force going upwards on the particle itself. Alright? And then you also have to count in its weight hitting the ground, 4mg. So that there is worth 10 marks a lot of the time, 5 to 10 marks easily, okay, for just two diagrams. Now that you've done that, it says prove that the acceleration of the wedge is g cos alpha g sine alpha divided by 4 plus sine squared alpha. Now, there's a problem here. Oh wait, there's not a problem because it tells us in part 3. If alpha equals 30 degrees, find the acceleration of the mass relative to the wedge. Okay, so what you do is you can denote it by 2 letters, okay? Now try and think. We'll call this F, okay? Acceleration F. Right? Acceleration F is actually the acceleration of the wedge relative to the mass relative to the wedge. Okay? And it's not the overall acceleration. Okay, so let's just start off with the formulas here, okay? So what we're going to do is we're going to do the 4 kilogram mass, 4 kg mass, and what we're going to do is we're going to draw lines. This here means perpendicular to plane. So it's basically along with R and downwards, okay? Now, overall, which way is it going? It's sinking downwards and going to the left. Yeah? It's going down to the left, so downwards is winning that battle there. Okay? So, what's going to happen here is basically MF sine alpha. I'm trying to think MF sine alpha. Sorry?
The particle is 1 kilogram at 4. And then the...
Oh, sorry. It's 1 kilogram. So it's 1, is it 1m or 4m? No, it's just m. Sorry, excuse me. Okay, so it's actually a m mass m, excuse me. Okay, so we have weight going directly downwards, okay, which is weight. The weight is mg cos alpha, okay, minus r. R is going directly upwards, yeah, and this represents the acceleration going downwards, okay, which is sorry, excuse me with that. P, yeah. Alright guys, so I just got my I'm just gonna had to reword this for a second, okay? It's actually P, or we'll call it A, okay? A is the acceleration of the particle relative to the wedge, okay? And F is the acceleration of the actual wedge. Just want to reword that, okay? Now, what we're going to have to do next is we're going to have to break up F into its components, okay? So to do this with F, F is going directly across, right? So F is going directly across, so it's going across and down, okay? So if F is going directly across, and I make this 90 degrees, and that's alpha, what this will mean is going directly up the plane is going to be F, what's going to be F cos alpha, yeah? And going down into the plane is going to be F sine alpha. Okay? Now you got to remember about this is that we're only talking about directly into the plane, directly down into the plane, or directly up away from the plane. So which component is it? It's going to be F sine alpha. Okay? Because we got to take in the overall motion. So that gives me my F sine, it's a force, okay? So net force is mass by acceleration, and in this case it's going to be m times, what do I have here? F sine alpha. Okay? So that's equation 1. Okay? Equation 2, r sine A equals 4mf. Now we have to figure out what does that mean, okay? 4mf is the wedge. The 4 meter wedge, or sorry, the 4m wedge, okay? You have 2 options. You can go left to right, or you can go up and down. Now why won't I pick up and down, can anybody tell me? If I pick up and down, it introduces S. I only need something that has an R in it. So I'm going to go left and right. Now, regards the wedge itself, okay, we have to figure out what component drives the wedge left and right. Okay? So, if you look at the reaction force, okay, see this reaction force going into the wedge? Yeah? This reaction force R has 2 components. Okay, so I'll just draw an arrow here. the reaction force has two components. It has a component going directly down and directly to the right. Okay? So it's about breaking it up here. So that is, if that's alpha, that's 90 minus alpha, and that there is alpha. So that's alpha there. That's R going diagonally right down. So driving the wedge to the right is going to be R sine alpha. Driving it directly down is going to be R cos alpha. So driving the wedge directly to the right is going to be R sine alpha. And that has to equal the overall acceleration of the wedge, which is ma, which is going to be 4m. And as said earlier, the acceleration going directly to the right is f. So it's 4mf. And that gives you your second equation. Okay? Now, what we're looking to do is we're looking to isolate f on its own. Okay? So, what we might do here, we're just going to look at both equations. So, where are both equations? Okay, so we have mg cos alpha minus r equals mf sine alpha. And then we have r sine alpha equals 4mf. Now, it's figuring out what to do here regards getting f on its own. So what I might try first and foremost is getting r on its own on the easier equation. So r equals 4mf all over sine alpha. Okay, once I've done that, what I'm going to do next is plug it in over here. So we're going to get mg cos alpha minus 4mf over sine alpha, and then it's going to be equal to mf sine alpha. At this point in time, I'm going to recheck the original question and see if it's everything I need is there. The original question says cos alpha sine alpha over 4 plus, so I'm allowed cos alpha sine alpha, so that's alright, and g. Okay? And I have to get f on its own. Now, I think the m's will cancel, like so, and then I'm going to multiply everything by sine alpha, so I'm going to get g cos alpha sine alpha minus 4f equals f sine alpha. Okay? Sine squared alpha, excuse me. I need to bring f over the other side, don't I? So it's going to be f sine squared alpha plus 4f all over g cos alpha sine alpha. Then I get f on its own, and f is going to be bracket 4 plus sine squared alpha, then divide it in, so it's g cos alpha sine alpha all over 4 plus sine squared alpha. Is that what I asked for? Yep. So prove that the acceleration of the wedge is g cos alpha sine alpha over 4 plus sine squared alpha. Okay? Acceleration of the wedge is f. Now, what asked me next is find the acceleration of the mass relative to the wedge. Mass relative to the wedge, okay? Now, understand, you need to learn off this combo here, okay? When you're looking for acceleration of the wedge only, your combination is up the particle that's on the plane, you do it perpendicular, and you use the formula for the wedge going horizontally. Okay? Once you've done that, that's your combination for your acceleration of the wedge. Your acceleration for the particle relative to the wedge needs a different formula. Okay? So the formula we need to look at now is the formula that's going up and down the wedge. Okay, so let me show you what's happening here. Okay, I'm just going to rub all this out for a minute. Okay, actually might need that, so sorry, it's this part here. Okay, so what we're going to do is we're going to zone in on the particle. Okay, now as discussed earlier, okay, what's driving it down the slope is the that's just mg, isn't it? That's not 4mg. Excuse me. So it's just mg sine alpha is driving it down the slope. Okay? Now, there's no friction, is there? So there's nothing opposing its motion. So in a friction question, you would have mu times r, and it'd be opposing its motion. Okay? But this question has no friction. And then what we can say is that, just give you a look at this here for a second. Yep. Okay. Now it has two accelerations. It has the acceleration p going directly down, but it also has an acceleration f opposing the motion. Now it's f cos alpha is opposing the motion. Okay. And p goes directly down and f goes directly up. So what we're going to say is this, guys. mg sine alpha, and mg sine alpha's direction is diagonal left down. It in turn will equal p. Oh, sorry, and it's a force, so it's mass times acceleration. So it's going to be m times p, which goes to diagonal left down, and diagonal right up is going to be f cos alpha. Okay? The m's will cancel on both sides. And what we're going to get is p minus f cos alpha equals g sine alpha. Okay, so what we're going to get here, excuse me for a second. I'll probably need to copy and paste that down here. This here, isn't it? Yep, this part here, okay. So, excuse me. Okay, so this part here is the formula I'm looking for. Okay. Now, what it tells me is the angle is what, guys? The angle is 30. Okay. Now, what I can do here is the following. I got rid of m, so I have g sine alpha into p minus f cos alpha. Whole point of the question is to find out what p is. So p therefore is f cos alpha plus g sine alpha. Now, what I can do next is, remember we got f on its own in the first question. That's f there, so all I have to do is replace it with g cos alpha, g sine alpha. G cos alpha, sine alpha, by another cos alpha, all divided by 4 plus sine squared alpha. Okay, and all of that it's been added on to g sine alpha. Now, there is absolutely no need to do any trigonometry to rearrange it and figure out what it is. Just put in your 30 degrees. Okay? So what we're going to get is p equals g cos 30 sine 30 another cos 30 all over 4 plus sine squared 30 all out plus g sine 30 here. Okay, now ignore the g's and just put this into your calculator and tell me what you get. Okay, just put the red part in. So the answer to this is 10g over 17, and that's worth your full 30 marks there.